Hi, welcome to this lecture on mathematical methods for biologists. In this lecture, we will continue discussing about statistics. So, the title of this lecture is Mean, Standard Deviation and Distribution, and the question we will answer is how to make sense out of a large data set. So, imagine that you have collected large amount of data. So, what is data? Data would be typically you do an experiment and you would get a number. So, this experiment would be concentration of a particular protein in many cells, right. This is some experiment, you would repeat this experiment many times and you would get concentration of a protein, of a particular protein of your interest, either as a function of time or in many cells. So, this is something that you could get. Other example could be like if you are doing more of a medical sciences, this could be some quantities like blood pressure, or it could be the amount of vitamin D in a population in a particular city or in a particular country. This could be with any other quantity that related to health. If we take that and if we write it as numbers, this would be a set of numbers. So, I would take some example, some set of numbers. So, let me write a particular example, which is in our case, let us call it like the blood pressure, for example, number. So, we will write only the smaller number. So, if you take a population and if you look at the blood pressure of the population, and if you write only the smaller number, which is around 80. So, we would write 80, you would get some numbers 82, 79, 85, 91, 90, 81, 80, 90, 92, 85, 85, 80, all these numbers, different numbers you would get. So, what you would have, this is one example. If you measure the gene expression level of a particular gene, right. If you look at quantify the concentration of a protein in many cells. So, you have many cells, a population of cells. So, you have a population of cells. In all of these cells, if you look at the amount of a particular gene expressed, the concentration, you could get some number. Again, that could be some, let us say the concentration is in micromolar or nanomolar, but it could be like 1, 3, 7, 5, 6, 1, 2, 3, 3, 1, 2, 7, 1, 5, 6, 7, 1, 3, 4. This could be the same, a similar set of numbers you would get from any other health related quantity, for example, you measure, or any quantity that you measure in a particular experiment that you would do. Whatever be the quantity that you measure, you would get a set of numbers for a population. Now, this set of numbers will be a huge table whose data set. How do we make sense out of this data? So, we want to convey that we got these numbers. How do we convey this? So, if we have to convey the whole information contained in a huge data set, and if we could use just one number, right? We have a huge data set, but to convey the meaning of the data, I could use only one number. If I could use only one number, I would use this number called mean or average. So, that is the importance of this number called mean or average. So, you have heard of this, which mean or average. What is this? We have many numbers 10, 15, 20, 10, 10, 25, 30, like many numbers we have. This is some measurement that we took in some experiment. This could be any quantity of your interest. So, let me call this x. So, this is x1, x2, x3, x4, x5, x6, x7. This is a quantity that you measured either in 7 different individuals or 7 different cells, or whatever be the context. We have 7 numbers and we wanted to convey the meaning of this. We would calculate this quantity called x bar, which is nothing but x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7 divided by 7. This is called the mean or average. So we would calculate average of these numbers. So if I do this, we have 25, 45, 55, 65, 95, 120 divided by 7 would be the answer here. So if I do this, I would get some answer which is, for these numbers, you would get some answer which is 120 divided by 7. So if I do for this, for these numbers, I would get 120 divided by 7, which is just below 20. So this is some number below 20. So something between 15 and 20 you would get a number, and this is the mean of all these numbers. So when do we use mean? We would use mean when we have to convey the meaning of a data set, but we could only use one number. Then that is the simplest way of conveying something. The mean gene expression, the average gene expression is 3 micromolar. That means if I add all the protein concentration or the concentration of mRNAs and divide it by the number of cells, I would get whatever 3 micromolar. That's what it means. If I just say that the vitamin D level in a population, the mean vitamin D level is 25 units. If I say that, that means there are many people. Some people will have 24 units, 22 units, 21 units, 26 units, 27 units, 30 units. And if I sum of all them and divided by the number of person in this, you would get 25. So this is the mean, something that we all know. And mathematically, this is written as x bar is sum over I xi divided by n. So this I will from 1 to n. There are n xi's. This is same as saying x1 plus x2 plus dot xn divided by n. So this is the thing called mean. However, very often if I convey something only by using one number, which is the mean, it could be misleading. There are examples where this kind of description could be misleading. For example, let us think of an example where we are talking about the average mark in a particular class. So let us say you have, or your own average mark that you got in various subjects. So you have various courses, course 1, course 2, course 3, and you got this mark and you are telling somebody the average mark. So if I just take a person X and that has 3 courses, so let us take the example. So this is a person whose name is Raju, is the person, and this person had 3 courses, course 1, course 2 and course 3, 3 courses, and let us assume that he got marks in these courses as follows. So let us say the marks one got was, the first got 70, 60 and 50. So these are the 3 marks one got, and the mean of this 3 numbers is of course 60. 50 plus 70, 120, 180 divided by 3. So the mean is 60. If there is some other person other than Raju, let's say Ajay, some other person, the same person, this Ajay got some marks, let us consider this marks as the following. Let us say he got in one course only 10 marks one got, right? In another course you got 60 marks, right? So and let us say this got 90 marks. So let us say 90 marks. So then this, so let us say 80 marks. This is fine. So this is 60 plus 90, 150 divided by 3. This is 6. So here the average would be 50. So here this mean is 50. So if I have this mark, and if this Ajay says I got 50% mark on an average, if I just convey only the mean here is 50. The mean is 50. So if Ajay says I got 50 marks on an average in 3 courses, that the person who listens would think that okay, he did reasonably well, he got 50% marks. But the fact that Ajay has failed in this third course, so the course number 3, Ajay got only 10 out of 100. So that means this course the Ajay has failed. But this does not get conveyed in this quantity called mean. So the mean is a quantity that conveys something, but there is some information which is not conveyed. The fact that there are some extreme numbers like 10, and in another course same Ajay got very high marks like 90 marks, so he performed very well. So this kind of information, the same thing, like if we have a fourth person could have a different set of numbers. So let us say another person, Kishore, could have numbers which is 100, 20 and 60. This would have the mean 60. So here also the mean of this and the mean of this is exactly the same. But even here Kishore has done very badly in course 3, while course 1 he did extremely well. So just by saying that the mean is 60, so both for Kishore and Raju the mean is 60 marks. But Kishore has essentially failed in one of the course. So in this course the Kishore is, while the mean is exactly the same. So just by saying the mean, one does not convey complete information, and we need to do something beyond. And that's why one uses this thing called standard deviation. So this quantity called standard deviation, which is how numbers, how far these numbers are from the mean. This quantity is very useful. So very often mean may not be necessary, or mean may not convey the complete information. That time one would use this quantity called standard deviation. What does the standard deviation tell us? It tells us that how much these variables, these random variables, whatever our marks or deviate from the mean. So this is what this standard deviation would convey. So if I just take the mark of the ith course or ith measurement and subtract the mean, I will get a number. If I sum this, I will get 0. So this doesn't make any sense. So I have to square and sum. So you take each number, subtract the mean from it, square and sum. This is called variance, and the square root of this is called a standard deviation. So this thing is called variance, and square root of this variance is called a standard deviation. So square root of variance is called standard deviation. So let's write. So standard deviation is the square root of variance, which is nothing but you take all numbers, subtract this, square it and sum 1 to n. So of course you have to divide. In this you have to divide by 1 by n minus 1. There is a, you have to divide this by 1 by n minus 1. Then only this would become the variance. So the 1 over 1 by n minus 1, if I divide, and the square root of this is called variance, which sometime would be represented as sigma or sometime by s, standard deviation s, which is sigma square is the variance, sigma or s. This is what we would use to represent this quantity. So let us take some numbers and calculate the standard deviation as an example. So let us say you measured vitamin D level in a group of people and we got the following numbers. So let us say the numbers we got from a group of people are 20, 25, 30, 25, 20. These are the numbers, vitamin D levels at 1, 2, 3, 4, 5 different individuals, and we know how to calculate the mean. So this is 120, 1, 2, 3, 4, 5 divided by 5. So this is basically 120 is the sum. So sum over I 1 to 5. So this is my xi, x1, x2, etc. So this is my xi, sum over I xi divided by n, 1 over n, which is 5. So which is 5 here. So this is 120 divided by 5, which is 24. So the mean is 24. So x bar is 24. Now what we need to do is to subtract x bar from each of these numbers. So let us do this little carefully. And if I look at these quantities, so this would be 20, 25, 30, 25, 20. The mean of this would be x bar, which would be 24. So the mean of which is 40 plus 50, 90 plus 120 divided by 5, which would be 24. Now the next thing to calculate standard deviation, you should calculate is xi minus x bar. So that is, I should subtract this x bar from each of this. So 20 minus 24 is minus 4, 25 minus 24 is 1, 30 minus 24 is 6, 25 minus 24 is 1, 20 minus 24 is minus 4. So sum of this would be 0. So that's not what we want. This is 8 in the minus 8 and plus 8, and this sum would be 0. But what we want is xi minus x bar whole square, which is 4 square, which is 16. This is 1 and 36, and 1 square is 1 and 4 square is 16. So this 36 plus 16 is 42 plus 52, 53, 54. So this would be 70. And sigma square is 70 divided by n minus 1. There are 5 of this. So we would do 70 divided by 4, and this would give us approximately, so this is going to be 16, roughly approximately close to 70. So whatever be this quantity, 70 divided by 4 would be the sigma square, and root of this 70 divided by 4, so sigma would be this root of 70 divided by 4, which is essentially root of 70 divided by 4 is 17.5. So, it will be like root of 17.5. So, this answer, the standard deviation is root of 70.5. So, which is approximately 4 something, 4 point something, right. So, if we have this number, so if we had this number 20, 25, 30, 25, 20, these were the numbers we had, and we had mean which is 24, and the standard deviation sigma was 4 point something, some quantity, which was, to be precise, which was root of 17.5. So, approximately 4 is the standard deviation you would get. If little above 4 is what you would get, which, so we have two numbers now to convey, which is, one is 24, which is the mean, and the standard deviation, let us say this is approximately 4.1. So, let us say approximately this is, let us take it as 4.1 or 4.2. So, let me take it as 4.2. So, if I approximately take it as 4.2, this number would be the standard deviation. So, a typical number here, I would write it as 24 plus or minus 4.2. That would be, if I just now convey two numbers, which would be 24 plus or minus 4.2. This is just for an example. So, I am now conveying, instead of conveying all these numbers, I could just convey one number, or I could convey two numbers, which is 24 plus or minus 4.2. So, there are two numbers, standard deviation and the mean. So, we could convey data sets by two numbers, mean and standard deviation. Now, what else can we do? Of course, we can do a few other things, and the ultimate thing is to plot this data as a distribution. So, how the numbers are distributed according to the ranges that we take. So, this is called a distribution. How? So, very often these are called like probability distribution or frequency distribution. So, we will talk about this, how this variable frequency distribution. So, this is another thing which we would discuss, how these numbers are distributed between some range of our interest. So, this is something that we would also discuss. So, imagine that you have marks or any quantity between some numbers, let us say between 0 and 100. So, we would ask a question. So, we would have a lot of numbers between, say, all possible numbers between 0 and 100. We could ask a question, how many numbers are there between 0 and 50? 10. So, in the data set given to us, so you have a huge data set, and this data set is between 0 and 100. All numbers are between 0 and 100. We could ask the following question, how many numbers are between 0 and 10? How many numbers are between 10 and 20? How many are between 20 and 30? How many numbers are between 30 and 40? And so on and so forth. Finally, we will ask how many numbers are between 90 and 100. So, let us say there are 5 numbers here, 7 numbers here, 8 numbers between 20 and 30, 10 numbers between 30 and 40, 2 numbers between 90 and 100. This will tell us a distribution of this mark. So, this I would call F, and this is the mark range. So, I can plot F versus this range of marks, and I would get some curve. So, this is called a distribution, about which we will discuss in detail later. So, to summarize what we have been saying, to describe a huge data set, we would use 2 or 3 things which we discussed. One is the mean or average, which we know how to calculate. The second thing is called the standard deviation, which is how much a quantity is deviated from the mean, and the third way is to take the whole thing and draw as a distribution, about which we will discuss in detail later, but we could compute the distribution from the data, which would have maximum information about this data and very easy to convey, something about which we will discuss. With this, we will stop this lecture and continue in the next lecture. Bye.